Let's finish up now with a slightly more complicated example of a double integral in polar coordinates, right? One that isn't over a polar rectangle. Okay. So we're going to find the area enclosed by one petal of this rose here, right? So let's just observe a couple things about this guy. R is cosine of 3 theta. Okay. What are some facts about this that we can figure out? Well, 3 is odd, so this guy has 3 petals. That's some important information. And then another thing we could use is, when is it 0? Right? So cosine 3 theta, actually let's skip the r here and just write 0. When does that equal 0? Well, we know that cosine is 0 at pi over 2 plus n pi. That's when cosine of regular theta is 0, but now it's 3 theta. So, right, it's cosine of whatever's inside, right? So whatever's inside has to be pi over 2 plus n pi. So 3 theta has to be that. And then that tells us that theta is pi over 6 plus n pi over 3. Okay? So that's when cosine of 3 theta is 0 at these theta values. Right? So, well, which ones are which here? Well, so let's just do a quick sketch of one of the petals. We know we have 3 of them, but we just want the area of one petal. Right? So, here's x and y. Right? So we know cosine is 0 at pi over 6. Our cosine of 3 theta is 0 at pi over 6, which is about right here. Okay? And we can check that at theta equals 0, the function is 1. So this is theta equals 0. This is theta equals pi over 6. Right? So from theta equals 0 to theta equals pi over 6, we're going in here. So, well, it looks like we have the top half. So let's try and go backwards here. All right. So before theta equals pi over 6, well, that's when n is 0. So if we do n equals 1, we can see that theta will then be negative pi over 6. So negative pi over 6. And then we get that the graph comes back in. And there's our petal. Right? So it takes theta. So let's start describing this region as D. Right? So we know r and theta. So we know theta needs to go, oops, not 0. Theta should start at negative pi over 6 and go all the way to pi over 6. Right? But what about r? Well, remember, when we're thinking of r, we have to start at the origin and work our way out. So let's say we start at the origin here, and if we work our way out, we hit the edge of the petal. And what is the edge of the petal given by? Well, so we start at the origin, right? And the edge of the petal, well, it's got to be given by this, cosine 3 theta, right? So this is the region, the one petal described in polar coordinates, right? So we have something that's a function here, but you know, we can do that in double integrals, no problem, right? So how do we find the area? Well, remember, as a double integral, the area of a region D, this is given as the double integral over D of dA, or 1 times dA if you like. All right. Well, we can describe d. So since this one has the function, we're going to want to do r first. Right? So we go from 0 to cosine 3 theta, and then from minus pi over 6 to pi over 6. Right? Hopefully those bounds make sense. But then there's the guy you should never ever forget about, r. Right? Don't forget this guy. Right? It's very crucial when you're changing from dA to polar that you get that r in there. All right, and then now we just do the integral. So minus pi over 6 to pi over 6. Now if we integrate that, we have 1/2 r squared from 0 to cosine of 3 theta, d theta. Okay, so this is just minus pi over 6 to pi over 6 of 1/2 cosine squared 3 theta, d theta. Right? And you might remember this now. This is when you plug things into the formula from Calc 2. Right? You'd integrate 1/2 r squared d theta. Right? But notice we kind of just picked that up for free. Right? So now just finish up this integral. To integrate that, we're going to have to use this trick here. Let's write it in blue. Cosine squared theta is 1 plus 2 cosine. That's not right. Let's try again. 1 plus cosine 2 theta over 2. Right? So we get a 1/2 from here and a 1/2 from here. So I'm going to write this as 1/4 minus pi over 6 to pi over 6 of 1 plus cosine of 6 theta. Right? And then when we integrate this, we have theta plus 1/6 sine 6 theta from minus pi over 6 to pi over 6. Right? All right, so that's 1/4 pi over 6. Plug in the pi over 6 to sine 6 theta, you're going to get sine of pi, which is 0. Then minus negative pi over 6, and again plus 0. So here you'll get pi over 3 divided by 4, so pi over 12 as your final answer. Right? So hopefully that all made sense. I encourage you to try many more problems of these because they can be tricky to get used to, but it should be no more tricky than what was in Calc 2. All right? So hope that all made sense, and see you next time.